Hi, in exercise W1 we have to design the drive system for the winder. This can be the winder from a paper mill, for example. And here we need to design for lowest possible cost, and we are requested to consider topologies with gearbox and without any gearbox. So let's see what we can do in DriveConstructor. So we enter the parameters for the winder drum diameters as well as the force on the drums and speed of the paper or fabric, whatever we are winding. So here we see we have three variants with the motors. By default they are induction motors, and we should take also into account the rated current and the working current of these motors, because it will affect the frequency converter choice. So we choose the cheaper frequency converter, wall-mounted variant. If we try another motor, so we see it is the same frequency converter because the working current is quite close, so no effect at all on the frequency converter. So now let's try permanent magnet machine instead of the induction machine. We see there are several variants, as it usually is in DriveConstructor, but maybe this is above average. 4 motors proposed by DriveConstructor, and working current is quite different for these motors. That's because their rated speed is different. So maybe we tend to take the lowest working current one, and the frequency converter is much smaller. You see, for the PM machine, it's just 90 kilowatt. So that's because of the higher efficiency and higher power factor of the PM machine. You see, power factor here is 0.95. But just to check what it was for induction machine, it is, if we scroll to the right, you find it's 0.7. It's so low because the induction motor here has quite low rated synchronous speed, so it's with multiple poles. That's why it is so poor. Now here let's look at the case with the gearbox. So the electric machines will have higher speed than in the previous case because they are geared up 3 times. So in this case we took helical gearbox with gear ratio of 3, just one stage, and the motors you see are immediately in the 1500 RPM range. So the machine is the machines are much smaller than before, but the frequency converter is more or less the same. So if you go to report, so every time you design a new system you can find all the parameters there for your benchmarking and choosing the cheapest variant. Thank you for watching.